So similar figures, a similar figure has the same shape but not the same size. Congruent figures have the same size and shape. So the first two they give us are rectangular prisms. What you'll notice is there is a ratio between all the sides that is called a scale factor. And so if you were to set all of these up, 8 over 20, comparing side to side, and then we have 2 over 5, right? And then we have 6 over 15. If you were to reduce all of those, you would get 2/5. Same ratio means that it is similar, okay? So if all of your dimensions have the same ratio, then these are similar figures. Look at the next one, non-similar figures, 8 to 12, 8 to 12, 7 to 10. Those do not reduce to the same fraction. Those are not similar figures. Even though they look somewhat similar, they're not the same. All right, if your ratio is 1 to 1, it is a congruent figure, all right? So if your ratio is 1 to 1 between your similar figures, then they are actually a special type of similarity called congruent, all right? So look at the next one. It says, key concept, two solids are congruent if the corresponding angles are congruent, corresponding edges are congruent, corresponding faces are congruent, and the volumes are equal. Congruent solids are exactly the same shape and exactly the same size. They are a special case of similar solids with a scale factor of 1. So look at the first example here. Determine whether each pair of solids is similar, congruent, or neither, all right? And so what they're doing is they're just going to compare the information that was given to them, all right? And so I typically put smaller over larger. They just put the first one over the second one. However you want to do it is fine. My answers on your answer keys when you get your review sheet will just do the first figure over the second, I believe. But it's up to you. It's the same. Whether the fraction is one way or the other doesn't matter as long as it's the same. All right. So let's look at these. They've given us the one of the sides, I guess. They've given us the height and I guess the slant height here. So we're going to compare those. If we're just take this first one down here at the bottom, 4 square root of 3 over 8 square root of 3. Yeah, so we have 4 square root of 3 over 8 square root of 3. Your square root of 3's will cancel, and your 4 over 8 will reduce. And then if you do this, you have to do the same way every time. So if I chose to put the smaller over the larger, make sure you do that the next time you do one. All right, so 4 square root of 7 over 8 square root of 7. If we do that one, 4 square root of 7 over 8 square root of 7. Once again, that's going to reduce to 1/2. And then if we look at the last one, 8 over 16, obviously that as well. That is going to reduce to 1/2 as well. My scale factor is 1/2. It is the same thing for all of them. So these would be considered similar. We would say this is similar.
I'm going to ask for this.
The larger cone here. So if I say I have 5 to 8. And one thing you do need to watch is orientation for some of these. So 5 over 8, it doesn't reduce, all right? Look at the next one. We have 12 over 15. All right, 12 over 15, does that reduce?
Yes.
It does reduce. It reduces by 3, so it's going to be 4/5. We have a little bit of a problem. Then that last one doesn't reduce at all, if you look. 13 over 17, right? This would indicate that these are not similar, all right, because my ratios are different. So we would say not similar. All right. If two solids are similar with a scale factor of A to B, then the surface areas have a ratio of A squared to B squared. And the volumes have a ratio of A cubed to B cubed. All right, so if you know your scale factor of your original figures, then you can look at the ratio for the surface areas and the volumes, and they actually just go up by dimension, which kind of makes sense, all right? So in this case, the example they gave us here, the scale factor from one solid to the next is 3 to 2. So that means the ratio of the surface areas is going to be 9 to 4, 3 squared to 2 squared. And the ratio of the volumes is going to be 27 to 8, 3 cubed to 2 cubed, all right? So it goes up by a dimension. So if you know the scale factor of the figure itself, then you can find the scale factor basically of its surface area and its volume. All right, look at example 2. It says mirror balls are spheres that are covered with reflective tiles. One ball has a diameter of 4 inches and another a diameter of 20 inches. Find the scale factor of the two spheres. All right, so the first thing they want us to do is find the scale factor. We're just going to say it's 4 to 20. We do want to reduce it. How does that reduce? Yeah, so you always want to reduce it before you start squaring or whatever. Find the ratio of the surface area of the two spheres. So we're going to take that ratio and we are just going to square it. So this one's going to be 1 to 25. All right. And then it says find the volume, the ratio of the volume. We're going to take that 1 over 20 or 1 over 5 rather, and we are going to cube it. All right. So 1 over 125. All right. So that would be the ratio between the surface area and the volumes. All right, so for the first one, you wanted to tell me if similar, congruent, or neither they were congruent. The second one was similar. Scale factor of the two pyramids was 4/3, which means the surface area was 16/9, 64/27. If you did 3/4 and 9/16 and 27/64, that is fine as well.